Hi, in this lecture I'm going to briefly go over the concept of confidence interval and the margin of error. So confidence interval is some interval that we represent besides just reporting the mean. So why do we need this? Because this what we studied previously, we are looking at population distribution, the gray one, that's the population distribution, but we simply cannot study everyone in population, so we select a sample out of that population. So let's say 25 individuals from the US population, we study them, calculate the mean for them. So let's say as an example, we want to calculate the BMI, mean BMI for United States population. We will just take one sample of 25 students, maybe from somewhere, Champaign Urbana, calculate the mean, and we'll based on that we'll try to say how does the mean of the entire US population in this particular examination looks like. So we report that mean. What happens by reporting only the mean is, like, say for example in this sample 2, we calculated the mean this, but the parameter or the population mean actually lies in here, so it's pretty much different than this one. So what we do is, we instead of just reporting one parameter, we are going to also say report the confidence interval. So which says that, okay, from this sample 2 we got this as mean, which could be mean of the entire US population, and it ranges from this much lower boundary to this much upper boundary. That means we are confident that it can vary within anywhere within this range. And we can see that this particular true parameter or mu of population lies within that particular interval. So that's a correct decision, right? So that's like the simple idea behind using this confidence interval and reporting confidence interval rather than reporting just the mean, right? Uh, With that, a little bit of theory, we can take random sample. Remember, random sample, simple random sample is always one of the assumptions to do z-score process in hypothesis testing. So that is very important. We can compute the sample mean and the interval plus minus 2 sigma square root of n around that mean. And we are going to look how does that look like. We already covered this rule. That's for one standard deviation, two standard deviation, three standard deviation, plus minus around the mean. So if we look at only 95% confidence interval, that's two standard deviation plus minus around the mean. Of all the interval computed with this method captures the parameter mu. So we are saying, okay, we are 95%. Whenever we report these intervals around the parameter, we say that we are 95% confident about that result. Uh, in other words, we say that we anticipate 5% of error. So we say 5% of the time it might not be true, or 5% of time whatever result we got were probably merely due to chance alone. So, and the simple random sampling, we take multiple samples, and you can see these are total 25 samples. And if it is 25 samples, in one of these samples, that's the one highlighted with this one red, we are going to have the error. That means we are not going to have the true population parameter within that interval. So one out of this 25 different samples, we are making an error. And if you calculate the percentage for that, or even keep it like that, it would be 0.04, or in terms of percentage, when you multiply by 100, it's going to be 4%. So somewhere approximately that's how much error we anticipate, right? So that's just brief introduction. Center of So in confidence interval, we always look for the center, that's mean, and there is some margin of error around that mean. So margin of error is nothing but that plus minus side around the mean, that error that we anticipate. So whenever we say we report any particular mean, we say we are confident that it would be from this lower bound to that upper bound. So how much that lower and upper bound away from the estimated mean, right? That is nothing but margin of error. So that is the negative margin of error on this side, on left side, and that will be positive m margin of error on the other side. So you can see that this total distance could be written as 2 times margin of error, right? Or magnitude of margin of error if you want to get the length of this. So that helps you in solving questions whenever they ask you to find the margin of error. So now we know that mu as an interval is within x bar minus mean, that's this side, and x bar plus 2x bar plus mean. So this would be, this particular value would be x bar minus margin of error, and this particular value would be x bar plus margin of error, and we know that this is the mean, so that's like x bar. So we also seen that confidence interval is also the area under normal distribution curve, and in this particular 95% confidence interval we look at this two standard deviation and area under that particular within that those particular boundaries. So we can also calculate the tails from this particular formula, which is not useful for this particular question, but just to highlight that point. So we had this question. So the question asks us to look at the confidence interval interpretation, and then it's asking us to calculate margin of error for the same question. So the interpretation part is pretty simple, so I'm not going to go over in detail that on that. So 95% confident interval for mean body temperature in Fahrenheit was computed as 98.5, that's the lower boundary here, and 98.4, that's here. So we know this x minus m, or this particular bar for this particular confidence interval, is 98.1, and this one is 98.4 because it's an upper bound, right? So that particular bound is 98.4 based on the body temperature from sample of 130. So n is that. So correct interpretation. So interpretation is pretty simple. Just go through these, but that simply means that we are 95% confident that the population mean body temperature is value that would range anywhere between this lower boundary 98.1 to this 98.4 degree Fahrenheit, right? And you can also report the mean if you want, but the interpretation is that we are confident that the population mean body temperature is a value between those particular range. So going back to the question that was asked by some of the students, margin of error, so how to calculate that. So it's pretty simple if you understand this mechanism or the concept behind it. So you know margin of error is around the mean, negative on this side, positive on this side, but sometimes you have been given only these coordinates, that meaning that you know this 95% confident interval, right? So this is 95% confidence interval. From that you will know these 2 points. If you know these 2 points, that means you can calculate this line, right? Distance between these 2 points. So how do you find that distance, this total distance? So that distance, or that's also a confidence in, not interval, but let's just call it a distance as of now. That distance is nothing but 98.4, that's the higher number, minus 98.1, that's the lower number, or the smaller number. But you can see that this distance, particular distance, also represents nothing but 2 times m, that's 2 times margin of error. That's why it becomes 2 times margin of error is nothing but 98.4 minus 98.1, and that's why the margin of error becomes 98.4 minus 98.1 divided by 2. And if you solve that, you should be able to get it as 15, 0.98, oops, and 0.3 divided by 2, that's 0.15, and that's why this is the correct answer.